Okay, students, let us solve this problem. This problem was asked in GATE 2015. It says that the incremental cost in rupees per megawatt hour of operating two generating units are functions of their respective powers P1 and P2, as we know in megawatt, and are given by. So these are incremental fuel cost. From the unit itself, we can observe that this is rupees per megawatt hour. If it will be in rupees per hour, that will be operating cost. So incremental fuel cost of plant generator 1 is this and generator 2 is this. See the limits. So both the units are having same limits. For a certain load demand, P1 and P2, demand on the plant, P1 and P2 have been chosen such that IC1 is this 76 rupees per megawatt hour and IC2 is 68.8 rupees per megawatt hour. See, these two ICs are not equal. It means the scheduling is not optimal. Clear? For optimal scheduling, the incremental fuel cost of the two units must be equal. We have seen. So from here we can observe that the loading is not optimal. Load shared by the two units are not optimal. Okay, whatever it is. So for these two, for any load demand is not given, but the two generators are loaded such that the incremental fuel cost of first generator is this 76 rupees per megawatt hour. For second, it is 68.8 rupees per megawatt hour. Okay. Now they are planning to schedule optimally. So if the generations are rescheduled to minimize the total cost, now they are planning to reschedule so that the operating cost will be minimum, means optimal load dispatch will be there. So P2 is, fill in the blanks. This was asked in GATE 2015. So whether it has been asked P2 or P1, we can find out, right? So first target will be find out the load shared by the two plants corresponding to these ICs, so that we can get the total demand for maintaining the generation equal to total demand. The two units are not optimally loaded, but they are loaded so that the total generation must be equal to the demand, right? So first target will be, okay, before that refresh our concept of optimal load dispatch. We have considered two cases. Case 1, when transmission losses are ignored, not considered. In that case, we have seen that coordination equation is dCi upon dPgi is equal to lambda. I is equal to 1, 2 up to number of generating units. So we can write dC1 upon dPg1 equal to dC2 upon dPg2 and so on. When transmission losses are ignored, loss not considered, in bracket you may write when we have denoted total transmission loss when this is equal to 0, means we have not considered. When we are going to consider the case when PL is not equal to 0, means we are considering transmission losses. In that case, we have seen that the condition modifies to Li, penalty factor, equal to lambda. This is the same incremental fuel cost of ith plant. So dC1 upon dPg1 L1 it should be equal to dC2 upon dPg2 L2 and so on up to kth plant, right? Where Li penalty factor is given by Li is 1 upon 1 minus del PL upon del PGI. What is del PL upon del PGI? This PL is function of PG1, PG2, PG3. We have seen it, right? Incremental transmission loss of ith plant, right? So these are the two cases, and based on that, various questions can be solved. So this problem falls in which category? Can you observe anywhere where it indicates that we are going to consider transmission losses? Nowhere. So no given means we are not considering. Once it will be given, it means we are considering. So not given, no need to worry, not consider, right? So we will apply this one, is not it? Okay. So in this problem, we have to find P2. and P2 is corresponding to optimal loading. For optimal loading, these two must be equal. So before that, just find out the total demand, right? So if IC1 is 76, it means this is IC1, it means this one will be 76. So from there we can get P1, means write down 0.2 P1 plus 50 is given as 76. Clear? So this implies P1 is, tell me the value of P1. Whatever it is coming out to be. Similarly, IC2 is this is 0.24 P2 plus 40 is equal to, this is 68.8. This implies P2 is equal to, tell me the value. P1 130. 130 megawatt. And what about this? 120 megawatt. Okay. So to meet a low demand, say PD, on the station, the two units are loaded, not optimally loaded, because these two are not equal. So, but they are loaded just to meet the demand of PD. So whatever the demand is there, that is being met by the two units. And corresponding to these two, IC1 and IC2, the two units are loaded at 130 megawatt and 120 megawatt. It means PD is known now, P1 plus P2. That is nothing but equal to 250, is not it? So 250 megawatt is PD. And we know that. Now, question is, if the generations are rescheduled, now you are going to change the loadings. You are going to reschedule the generations from the two units. It means, so that what is your target? To minimize the total cost. That means now you are going to load the units optimally. Optimal load sharing condition will be applied now. So what is that condition? That condition is these two must be equal. If units are more than 2, then for 3, ICs must be equal to lambda, isn't it? So for optimal load sharing, we will equate these two. So this is one equation, and second equation will be IC1 for optimal load sharing. IC1 will be equal to IC2. This implies, equate these two. This implies 0.2 P1 plus 50 is equal to 0.24 P2 plus 40. So we have two equations, two unknowns. So this can further be written as, okay, two equations, we have equation 1 and equation 2. So two equations and two unknowns, P1 and P2. So P2 has been asked. Now the values of P1 and P2 will be corresponding to optimal loading. Is not it? So tell me the values of P1 and P2. Whatever P1 is coming out to be, our target is to find the value of P2. Okay, tell me the value of P2. 36 megawatt. If someone asks P1, so you can use this equation, 250 minus this will be this, is not it? So this was asked in GATE 2015. I don't think that this level is tough for you. I think you find it easy or tough? Easy. Once you know the concept, you can apply. Right? So let us see one more problem. Asked in the same exam in different sets, set 1 or set 2, whatever, means GATE 2015. Any question in this problem?